Okay, one of the major topics in this chapter is reference angles. This is the rules for reference angles, but I don't want you to write these down. I want you to know by definition what a reference angle is, and then be able to kind of figure out try to figure out the rules pretty much on your own. Reading the definition of reference angle, this might not make sense, but if theta is a non-quadrantal angle in standard position, and what we mean by non-quadrantal is it's not like a 90-degree angle. It's not a 180. It's not a 270. It's in a quadrant. If theta is in first, second, third quadrant in standard position, then the reference angle for theta is the positive acute angle. That is one thing you need to know. That a reference angle will always be positive, and it will always be an acute angle. Every angle has a reference angle. The angle is formed by the terminal side of theta and the positive or negative x-axis. It's formed by the terminal side and the positive or negative x-axis. Now, let me show you what that means. If you have a 150-degree angle, the reference angle for a 150-degree angle is formed by the terminal side, and you see the terminal side here. It's the side where your angle stops. This is the terminal side. The reference angle is formed by the terminal side and the positive or negative x-axis, whichever one is closest to. This is the reference angle. It kind of goes back to a little bit of geometry, some minor concepts in geometry. To where if that's 150, we know that the straight line's 180 all the way around, so this reference angle here is 30. Okay? The reference angle of a 150-degree angle is a 30-degree angle. Let's do another one. Scroll back down. Let's do a 200-degree angle. A 200-degree angle, if you graph it, start here. There's 90, 180, a little bit further past this, 200 degrees. If you need the reference angle of a 200-degree angle, again, a reference angle is formed by the terminal side. Here's your terminal side. And pretty much the best way of saying it is the nearest part of the x-axis. Here's your x-axis. To this angle here, here's the nearest part of the x-axis. So we want to know how big is this angle. That's your reference angle. Reference angles are always acute angles, okay, formed by or closest to the x-axis here. If this is 200, somebody tell me how far past that 180 is that? 20 degrees. For a 200-degree angle, your reference angle is 20. Okay, and this is important to us, I promise. I'll show you what this is used for in just a second. Scroll down, let's do another one. Let's do a 330-degree angle. 330. Well, I want to know the reference angle of 330 degrees. Here's 90, 180, 270, 360 is too far. So 330 is going to be about right there. Closest part of the x-axis. How far away from 360 are we there, Skylar? 30 degrees. So the reference angle of a 330-degree angle is 30 degrees. Now the rules that I told you I don't want you to write down because it's just extra stuff to memorize. Those rules state that if an angle is in the first quadrant, your reference angle is the angle. That's your first rule. Let's look at why that's true. If I want to know the reference angle of 45 degrees, well, the nearest part of the x-axis is here. What's my reference angle? 45 degrees. So if you're in the first quadrant, your reference angle is the angle. If you're in the second quadrant, how do you find the reference angle? Anybody tell me? You'll be somewhere like right here. How are you going to find this reference angle? Subtract from 180, right? If you're in the third quadrant, if this is your angle, how do you find this reference angle? You'll take 180 from it. And if you're in the fourth quadrant with your angle, if it's somewhere like this, you'll take your angle from 360. That's what those rules state, but we don't have to learn those rules because you can figure out those rules. But again, your reference angle is simply the closest angle, or the angle formed by the closest part of your x-axis. Bless you. Moving on. For each angle theta, sketch a reference angle theta prime and give the measure of theta prime in both radians and degrees. Ooh, that's fun. First problem, 120 degrees. I'll let you try that one on your own. I will sketch it for you. 90, 120 is about right here. I need to know the reference angle of 120 degrees. Okay, here we go. Henshaw, did you get the reference angle? 60 degrees. Any question on how we did that? The actual words from geometry was a linear pair. These two angles form a linear pair. They add up to 180. So your reference angle is 60 degrees. Anybody, that's going to be pi over 3. 180 divided by 3, which is 60. Okay. The second one, 7 pi over 6. Let's sketch it. Clear. Does anybody know where 7 pi over 6 is? I don't. What am I going to do with 7 pi over 6 before I start working with it? I'm changing it to degrees because I have no idea. These radians, they confuse me, right? I have no idea where 7 pi over 6 is. So here's what I do. Pi over 6 is how many degrees? 30, right? 180 divided by 6 is 30. If I have 7 30s, I believe that would be 210 degrees. So I've got 90, 180, 270, so 210 somewhere down here. I need the reference angle, which will be here. I'll give you a second to try that one. Elizabeth, if this is 180, how far past that 180 are you? What is your reference angle? 30 degrees. Which is, again, pi over 6. No, that one was 60, wasn't it? Pi over 6 is 30 degrees. Okay, 180 divided by 6. Third one, 690 degrees. Okay, now we're getting into huge angles. How in the world are we going to find the reference angle for 690 degrees? Any ideas before we begin? Do we really want to draw 690? What's the easiest way to draw 690 degrees? Find its, does anybody remember the word? Find its coterminal angle. Find the smaller coterminal angle. I'll tell you what, instead of just taking away 360, do it twice. Take 720 away for me. What do you get? Negative 30. That's really easy to graph. Negative 30, bless you. Negative 30 just says go 30 in the negative direction. There's negative 30 degrees. And with doing so, that made my reference angle a whole lot easier. Anybody know what that reference angle is? 30. Okay, how far are you from the nearest part of the x-axis? Now, could I have done it the other way? Could I have said 690 is the same thing as 330? Sure. If I'd have done it that way, then I took my 360, took away 330, and I would have found out again 30 degrees or pi over 6 is my reference angle. So we're going to be using those coterminal, and that's one of the main reasons we learned coterminal angles. We're going to be using coterminal angles when we're talking about reference angles to take away rotations, to make it a little bit easier to graph. And the last one, negative 7 pi over 4. I really don't like that. Let's add rotations to that. Well, first off, let's change it. Pi over 4 is 45. Somebody multiply that by 7 for me, please. And that gives me negative 45. Is it 315? Negative 315. I don't like negative 315. Add a rotation to that. I want to know where is negative 315. Add 360 to that. What do you get? Thank you. So negative 315, if you start here and you go negative 90, 180, 270, 315, that's the exact same thing as going positive 45. So my reference angle is 45. Okay, the next problems, I don't want you to try. The next problem says find the sine, cosine, and tangent of these angles. The words that are about to come out of my mouth are the most important things that you're gonna hear today. The value of the sine, cosine, and tangent of an angle is identical with the exception of some positives, negatives. Now, I'll teach you about that in just a second. The value of a sine, cosine, or tangent of an angle is the same value as the sine, cosine, or tangent of its reference angle. Okay? Let's make sure I don't want to go there yet. Show you what I mean by that. if you want to find the sine of, let's do a common angle, the sine of 150 degrees. How do I find the sine of 150? Because I told you, you're actually not going to just memorize 30, 45, 60, 90, and 0, but you're also going to memorize that whole grouping of common angles. But here's how you're going to do it. Really, you've got memorized now everything you're going to have to memorize. To find the sine of 150, you find the sine of its reference angle. Okay? And it's going to be closely related to the sine of its reference angle. And I'll prove it to you. Here's 150 degrees. Its reference angle would be 30 degrees. We take out our calculator, and I just want to use this to prove it. What is the sine of 30? Anybody? Without a calculator, sine of 30 is 1/2. Thank you. The sine of 150 is 1/2 as well. The sine, cosine, and tangent of an angle is going to be the same as the sine, cosine, or tangent of its reference angle, with one minor exception sometimes. Let's do the same thing for cosine. We know the cosine of 30 degrees. That's actually root 3 over 2. If you do the square root of 3 divided by 2, it's 0.866. So the cosine of 30 is 0.866. Now, that should be the same thing as cosine of 150, right? Let's try it. Cosine 150, enter, close. It's negative 0.866. So that's going to be the only difference. Sometimes it'll be the positive version, sometimes it'll be the negative version. Here's how you can figure out whether it's going to be positive or negative. All students take calculus. That's how I remember it. All students take calculus. I know that I'm not trying to force you into taking calculus after Christmas, but this is just how I teach this. All students take calculus. Here's what those things stand for. Notice that I've got your quadrants drawn here. First, second, third, fourth quadrants. In the first quadrant, sine, cosine, and tangent will always be positive. Everything is positive. In the second quadrant, sine is positive. Everything else is negative. In the third quadrant, bless you, what's T stand for? Tangent. In the third quadrant, tangent is the only thing positive. Sine and cosine are negative. And in the fourth quadrant, cosine is positive. Tangent and sine are negative. All students take calculus. Or some people just say ACTS, A-C-T-S, and they go in the other direction. So either left, where all students take calculus. Don't rely on both of them because you're going to get confused. Do I go this way? Do I go clockwise? Do I go counterclockwise? So you learn one or the other. I'll reference it as all students take calculus. And we go quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so let's work some problems. And let me show you what I mean by this. Let's save these up here. Let's do some simple ones first. If I ask you to find the sine of 300 degrees. On your quiz, on your pre-class quiz, that's one of your common angles. So how are you going to do the sine of 300 degrees? If you need to sketch it, it's going to slow you down some, but if you need to sketch it, here we go. There's 90, 180, 270, 300 somewhere down here. Somebody help me with my reference angle. What is it? Careful. From 360 it is 60. Reference angle 60. So how do I find the sine of 300? I find the sine of 60 because I know it. I know all those I know 30, 45, 60. I know those reference angles. So first step, I find the sine of 60. Well, before then, let's determine the sine of 300. I need to know, first off, is it going to be positive or is it going to be negative? Since it is in the fourth quadrant, all students take calculus. The C is down here. The only thing that is positive is cosine. So sine will be negative. And then you simply find the sine of 60, which is, so the sine of 300 is negative root 3 over 2. I'm going to do a lot of these. This will probably be one of the only things we do today.